In this class, we are going to deal with satellite navigation techniques. In the modern life, we are using the techniques in many contexts. For example, every time you use Google Maps to find your location or to navigate to some known or unknown place, you are seeking the help of satellite navigation techniques. So, how these techniques work? What are the components of the system? We will try to understand in a very simple way and in a very general way how the process happens. Now, let us start with a few basic questions. So the questions are displayed here. It seems these questions are somewhat philosophical. Who am I? What am I? Where am I? Where am I going? Okay. And you will have some answers also. If you forget philosophy, we have some real answers. Who am I? I am Krishna, but not Rama. That's sure, no? When you say Krishna, it is perfect that you are Krishna and you are not Rama. And what am I? I am living cells, not dead cells. Clear? And so there are a lot of such questions. Where am I? You have some answer. Where am I going? You will have some answer. But the point is, the answers will be accurate if your knowledge is pakka. If you have bad knowledge, you will have bad answers. That is true. So to get answer to some questions like what, where, when, who, etc., your knowledge should be very deep, or your knowledge should be clear to get nice answers. So that is what is important, and that is what I wanted to make you convinced through this slide. So you should have clear knowledge to get some answers. Now look at the next slide. Here, this is some cartoon where this dog has poor knowledge. And what is his assumption? He just thinks that all cats have 4 legs. He has just seen that he has got 4 legs. Okay, the dog has 4 legs. He just knows that. So I have 4 legs. He thinks, okay, I have 4 legs. Therefore, I am a cat. Why? Because this dog hasn't seen himself. Okay, he hasn't looked to other dogs. He hasn't seen other dogs. The only animal he has seen is a cat. So what does he think? He thinks that animal is having 4 legs. So I am similar to the other animal. I am similar to a cat, because his knowledge is very poor that he has not seen any other animal except a cat. So he just thinks that I am a cat. The dog appears to be a cat for the dog himself. So it's a very exaggerated thinking process or a very exaggerated cartoon. But this is the harm or the danger of poor knowledge. So that is what this picture tells you. Now look at the next slide. So where we have, we can just forget who and what. Let us find where. Where, to where, how, and the route. So you are just concentrating on to only one question word, that is where. So I am at what location? Where am I? To where means where am I going? Or where should I go? How? How can I reach there? Or the route, which is the best route to go there? Whether I should go by air, whether I should go by train, or whether I should go by one particular place, or like that. So you know that when you are going to your house, there are different ways, and which route you will decide the route route by which you have to go, and the decision comes by thinking different factors. Sometimes the speed matters, sometimes the length of the path matters, sometimes the accessibility through bus, etc. matters. So there are these different aspects are involved when you are fixing a route. So where, to where, how, and the route. We address all these questions in the title navigation. So this is what simply navigation is. Or where are you now? You wanted to go somewhere, and how you can reach there, which is the best way to reach there. These are things we call in a general term called navigation. As I have shown in the previous slide, answer to any such question will be accurate only if your knowledge is perfect. So answers will be accurate if our knowledge level is sufficiently high and precise. So that is the message of this particular slide. Positioning and navigation will be accurate depending on your knowledge level. How precise the measurements you make, that decides the accuracy of the positioning and navigation. Where to go, how to go, etc. are determined by the knowledge you have, or the measurements or the accuracy of measurements you take. They all should be perfect to have perfect navigation. So in the history of mankind, we were using different types of navigation techniques in the past. For the first man, when the science was not developed or advanced, they were looking onto the skies to know the direction, like the sighting of a star, or the crest, the face of a moon, etc. They were using to, in one way or the other way, to determine the time and direction, etc. Later, at one time, they have developed some sort of a pictorial map, and using that, these people travel from one place to another. And when compasses were invented, or the magnets were invented, the compass became their navigational tool. And other instruments, like when you are going into the sea, there are other electrical equipments came into play to know the places, to navigate into the sea and all. And later came the electronic navigation techniques, where when the electronics came into existence, we have some good boom or good advancement in the area of navigation, when the radio navigation came, so that the radio waves were used to know the position of some vessel in the sea, or some sort of things like that. Radio waves were used to navigate. Radar, radio detection and ranging. Suppose you wanted to know the position of a flight or of an aeroplane in the sky, you were using the techniques of radar. So radar, the techniques I am not going to explain. It's a very popular device. And all these things, radio navigation and radar, etc., were primarily to know the position of other objects. For example, I am standing on the surface of the earth, and I am standing at one position, and I wanted to know the position of another object. For example, a ship in the sea, how far it is from the shore. So you can use the radio navigation. A plane on the sky, how far it is from here and what is its velocity, etc. can be analyzed using radar. So in all these things, we were just detecting or just analyzing other objects, or the position of other objects, and not our own position. But later came, or the recent development in navigation is a satellite navigation technique, which is the topic of this lecture, as you know. So by satellite navigation, we have a new type of position determination, that is the position of ourselves, where we are. That is what is determined when the satellite navigation came into existence. So if you know where we are, you can also find out where the other people are, etc. There are a lot of techniques involved. So the primary difference between earlier navigation techniques and this particular satellite navigation, in one aspect, satellite navigation can be used to find out the position of oneself. Okay. Well, to understand satellite navigation technique, let us take the popular example, that is global positioning system. It is a navigation system using satellites developed by United States. And by definition, it goes like this. It's a constellation. Global Positioning System, or GPS, is a constellation of Earth orbiting satellites. It's a constellation. It's a group of satellites maintained by US for the purpose of defining geographic positions on and above the surface of the Earth. So if you are standing on the surface of the Earth, or if you are flying on a flight, and or if you are in a spaceship, wherever you are, both on the surface and above the surface of the Earth, you will be able to know your position, your longitude, latitude and altitude, and such things with the help of global positioning system. And for we people who are standing on the surface of the Earth, only longitude and latitude are important. We may not be dealing with altitude because we are always on the surface of the Earth. Well, if you look onto the history of the global positioning system, the project was started by United States Department of Defense in the year 1973.
Even though it was started in 73, the project became fully operational and completed only in the year 1994. See, it has taken almost 20 years to be completed. Such a vast project. And the first name given to the system was DNSS, Defense Navigation Satellite System. Primarily, it was aimed for the usage of military and defense. Later, the name was modified as Navstar, Navigational System Time and Ranging. And at a later stage, they again changed the name of the system as Global Positioning System, or GPS, as we use today. Along with the US military applications, now this service of the Global Positioning System is available for civilian applications. Not only in US, they have given access to this GPS to other countries also. So GPS is currently used worldwide. As I told you earlier, the primary use of the GPS or any satellite navigation system is to locate yourself. So if you have a GPS receiver with you, you will be able to know where you are. You can know the longitude and latitude of the position where you are located. Also, it can be used in a community scenario also. If a group of users are there with the GPS receivers on their hand, and in that scenario, a particular user will be able to know where the other user is. So one GPS user can tell where exactly the other user is. It can be used as a tracking system. So anybody can track any other people. Now let us try to understand what are the segments in GPS. GPS has got three different segments, namely space segment, control segment, and user segment. We will see all these segments in detail soon. So this is the pictorial representation. This satellites and all which is required for locating something is called the space segment. And obviously all these things has to be controlled by some master control and other control stations on ground, and they are termed the control segment. And obviously there will be the user segment. Actually, we people who are using this forms the user segment. So the satellites form the space segment, the control things, the control stations, etc., on the ground forms the control segment, and the users all over the world forms the user segment. The space segment consists of satellites mainly. In the constellation, there are 24 satellites, but obviously there will be more number of satellites operational at a given time. The minimum requirement is 24 satellites. All satellites have 12 hours period. That means they will revolve around the Earth twice in a day. And the altitude of the satellites is 20,200 kilometers. It is well below the geosynchronous orbit. You know that the geosynchronous orbit is around 36,000 kilometers above, but it is this 20,200 is well below that. And the speed of the satellite is 3 kilometers in 1 second. In 1 second it travels 3 kilometers. It's a very low power, the satellite. Its transmitter power is only 50 watts or less. And the most important point regarding the space segment is that at any given time from any point of Earth, 5 to 8 satellites will be visible. So if you are here at a particular place, and if you look onto your skies, 5 to 8 satellites will be visible for you. In the sense, if you have a GPS receiver in your hand, it will be able to receive signals from at least 5 satellites at a time. It can be 5 to 8. The first satellite in the GPS system was launched in 1978. And the 24th satellite, as you know, 24 satellites are required for the full operation of the GPS. So the 24th satellite was launched in the year 1994. And each satellite has a lifespan of 10 years. When I say 10 years, it is not exactly 10 years. Satellites are operational even beyond that 10 years time. And satellite has to be replaced occasionally also. Now it is 2020. So we don't have the original satellites which was launched in 1978. Now maybe we have replaced satellites with the new ones. Anyway, at any time, 24 satellites are required for the full operation of the system, and in practical, there will be more than 24 always on the skies. Yeah, this is a typical schematic of a typical GPS satellite. Now we will come across control segment. You know that there are at least 24 satellites in the skies, and all of them require some sort of a monitoring. Monitoring in the sense they will be monitored for the trajectories and they will be monitored for their technical health. Trajectories of a satellite is a calculated one, but the satellites in the course of time will differ from these calculated trajectories simply because there are some friction factors like solar wind ions or electrons will be there in space. Even though we say that space is empty, there are certain particles present in the space. So satellites constantly come across these friction particles, so that their trajectories, their speeds may be different from which we have calculated. So their trajectories may go down, their orbits may come down. So that is not desirable. So that has to be corrected. Similarly, all the satellite components like its transmitter health, its power, its transmitted power, its battery, etc., are to be in a good condition. So all those things regarding all these 24 satellites has to be checked. So for that, we have some monitor stations. So monitor stations are scattered over the globe at different places. They collect information from these satellites, from these 24 or more satellites which are in the skies, and occasionally they will calculate any errors in the observed parameters from the satellites, and these errors has to be corrected. For that, the monitor stations collect the parameters and they will make some calculations and should upload to the satellites what are the corrections to be made or how the defects are to be rectified. So this uploading is done by a station in Colorado. So that station is called the master station, master control stations. So it is the duty of this master control station to upload data required for correction of trajectories and correction of equipments in different satellites. So these are the distribution of the monitor stations as well as the master control station. Throughout the globe at different positions we have the monitor and control stations. And this is how the process works. The satellite is in the sky and there are monitor stations which are observing the ephemeris and the clock. Ephemeris means the trajectory information and other information regarding satellites. And the clock is also important, that I will come later. The clock information or the time information of each satellite is important. So that also is collected by different monitor stations. And all those monitor stations pass these informations to the master control stations. Master control station at Colorado, that is technically known as Falcon. Falcon AFB is the master control station in Colorado. And this master control station just analyzes the data collected from different satellites and supplied by the control stations or the monitor stations. And the master control station takes a decision what are the corrections to be applied to different satellite trajectories and different satellite equipments. And those information are uploaded to the satellite in the upload stations. The upload stations may be different at different locations sometimes. So anyway, this master control station at the Colorado, otherwise known as Falcon AFB, is making decisions. The monitor stations collect the information and the upload station upload the information. The decision is taken by the Falcon AFB or the master control station at Colorado. So the last segment is the user segment. User segment, as we know, is the GPS receivers all over the world and the users themselves. And if I have a GPS receiver, I'll be able to receive signals from different satellites on my skies. And using the information collected from these satellites, I'll be able to calculate my position, my speed. If I'm traveling in a vehicle or an automobile, I will be able to calculate my speed. One important thing regarding the receiver is, as the name indicates, it can only receive. GPS receiver in your hand can only receive signals from the satellites. You cannot send anything to the satellite. by collecting information from the satellites, your receiver is able to calculate your position and speed. And this is typical GPS receivers which we are using. Your mobile phones are, most of your mobile phones are GPS receivers, that also we must understand. And most of the modern cars have GPS receivers which they use for fixing their position and navigation. Now let us come to the actual process of locating something. For that, let us take this example. How we fix position on this screen. See, let us have a point P on this screen. How we say that it is at this point P? Where is P? If somebody asks you where is P, how can you locate it? So one way is to fix three different points A, B and C. For example, I can say that P is at a distance of 3 meters from A. So when I say that P is at a distance of 3 meters from A, it does not locate P because I can draw a circle with radius 3 meters centered at A, and the point can be anywhere on the circumference of this circle. Okay. So I will use another reference point. Apart from A, I will say that my P is at a distance of 3 meters from A, but also it is at a distance of 2 meters from B. Now I will have two circles. One centered at A with 3 meter radius and one other centered at B with 2 meter radius. So there are two circles and they intersect at two different points. So that means your P is not located even now because P can be either at one intersection or at the other intersection. So I just take another circle centered at C and say that P is at a distance of 1 meter from C. So now I have three different circles. One centered at A, another centered at B, and the third one centered at C with different radii 3 meter, 2 meter and 1 meter. See. So all these three circles will intersect at a single point and that point is P. There are no other point which is 3 meter away from A, 2 meter away from B and 1 meter away from C. The point is unique. You will not have any other point which satisfies these three distance conditions. So to fix a position on this screen, you require three different points, three different reference points A, B and C. And if you draw circles centered at these three reference points A, B and C with the corresponding radii, the three circles will intersect at the desired location. Okay. So this is how you can locate one point on the screen using three reference points. So this is the scenario. To fix position on the screen, you have to fix three reference points, say A, B and C, and find out distances from P to these reference points. Draw circles centered at these points. The intersection of three circles fixes the position. Now we come to 3D, three dimension. The point and the screen, etc., are two-dimensional aspects. Now we come to the actual locating position, that is three-dimensional approach. So when you switch over to 3D or from 2D, 3-dimension to 3-dimension from 2-dimension, your concept of circle has to be changed to space. Suppose I am here and I see a GPS satellite which is 11,000 miles away from me. I already told you that at any time, from any point on the surface of the earth, you will be able to see 5 to 8 GPS satellites. So one such satellite, say, is at a distance of 11,000 miles from me, and let us call it as a satellite A. So if I draw a sphere, not a circle, because 3-dimension you will have a sphere. Okay. So if you draw a sphere with center as this particular satellite and radius equal to 11,000 miles, I will be on the surface of the sphere. Okay. I will be anywhere on the surface of the sphere. My location is not fixed. I can be anywhere on the surface of the sphere with center as this satellite A and radius as 11,000 miles. So what I do again? just as in the two-dimensional example, I will choose another satellite, the second satellite. Okay, I will call it as satellite B. I'm already at a distance of 11,000 miles from satellite A, and at the same time, I am at a distance of 12,000 miles from satellite B. Okay, so I will be having two different spaces whose senders are two different satellites. Okay, and these two spaces will be intersecting. So that intersecting area will be a circle. You just imagine two spaces when they are intersecting, that will form a circle. Okay, so my position is now narrowed down. To satisfy 11,000 miles from satellite A and 12,000 miles from satellite B, my position is now narrowed down to the intersecting circle or the circumference of that intersecting circle. I can be anywhere on the circumference of that intersecting circle. Okay. Again, my position is not fixed because it can be anywhere on that circle. So, I just see another satellite, the satellite C, which is at a distance of 30,000 miles from me, say. So now I have three different spaces. So if I just imagine the intersection of three different spaces, then I will get two different points, not circle or anything. So my location is now narrowed down to one of the two intersecting points of these three different spaces. Now, to actually fix the position, we need one more satellite, right? Then if you have one more satellite, 2 point scenario will be changing into single point scenario. And obviously sometimes we will think that a fourth satellite is needed. But in many practical situations, this fourth satellite is not needed because three satellites will intersect to give 2 points, I told you. Three spheres will intersect to give 2 points. One of the points may not be acceptable for us. For example, one point is say one point is on the surface of the earth and the other point is on space, and you know that you are on the surface of the earth, so you can just eliminate the other point. Okay, like when you are calculating the root of a quadratic equation, sometimes the time, suppose you are just finding out the value of t from a quadratic equation, there are two roots for this quadratic equation. One root may be minus, no? So you will just say that that root is not acceptable because time cannot be negative. So similar is the case here. You are intersecting three spheres. You are getting 2 points. 1 point may not be acceptable in the real situation. So three satellites itself is sufficient in many situations to locate my position because the other point, one of the 2 points, is not acceptable. So theoretically, but you require 4 different satellites, but 3 is sufficient. So this is how the GPS works. GPS uses satellites as reference points. The position on the surface of the earth or in space can be fixed by measuring distance to 4 reference satellites. The intersection of 4 spheres fix the position. These are all theoretical thing. But usually 3 reference satellites are enough because one of the points it can be eliminated for obvious reasons. So you know your position with respect to satellites. And one of the requirements to fix your position is that you must know where the satellites are. Then only you can calculate your exact position. You see, suppose I am saying that I am 1,500 kilometers away from Delhi. I must know where Delhi is. Otherwise, there is no point in telling that I am 1,500 kilometers away from Delhi. Similar to that, when I am saying I am 11,000 miles away from satellite A, I must know where satellite A is. Otherwise, my calculation will be completely wrong. So that information is very important. Only if you know the distances to the satellites, 3 or 4 satellites, and only if you know where the satellites are at present, then only you will be able to calculate the exact location. Then only you can convert your location information into latitude, longitude and altitude, whatever convenient way you are specifying your location, you can convert it into that particular coordinates. So the information of where the satellites are at present is important. So that must be made available to the GPS receiver. Suppose I have a GPS receiver in my hand, I should know where satellite A is, where satellite B is and where satellite C is at this particular moment. And this information is what I have already mentioned in some other slide as ephemeris. Satellite A is where is satellite A now? At this moment, where is satellite A now? Where is satellite B now? Etc. etc. I must know, my receiver must know. Then only the receiver should have this distance information. We'll be getting this distance information. So the reference points must be known. So the technique we use here is, we have just seen the control segment. The control segment will be collecting the satellite information, where all the satellites are, what are the trajectories of all those satellites that is available with the control segment. The control segment will be uploading the satellite informations to all the satellites. All the 24 satellites will have the satellite information. That means where the other satellites are at a particular time. Those information is, say for example, the first satellite will have information regarding 23 other satellites and where are those satellites at particular time. So this information is called ephemeris information. All the satellites is having the satellite information of all other satellites. These things will be transferred to your GPS receiver before it makes any calculation. So my GPS receiver is able to know where are the satellites at a particular time. So then I calculate, then I just measure the distance to different satellites and will find my location. So this ephemeris information, where the satellites are at a particular time, is important, and those satellite information are available with all the satellites, and my GPS receiver will collect those information from satellites in the scene. So the GPS works in different steps or stages as seen. First of all, the receiver on your hand has to know the satellite positions. That is called ephemeris. As we have already discussed, this ephemeris is available with all the satellites, and when your receiver is switched on, the receiver downloads this ephemeris from the satellite. Second one is the measuring of distance to satellites. We know that 3 different satellites are needed to locate your position. So you need 3 distances to be measured. So how to measure the distance? We cannot directly measure the distance from the receiver to the satellite. So instead what we do is, we are measuring the travel time from this satellite to this particular receiver. Suppose the satellite sends a particular code at a particular time and it is received in the receiver after 2 milliseconds. So you know the travel time, that is 2 milliseconds. You know the velocity of electromagnetic wave, and if you know the velocity and the travel time, you can very well calculate the distance. It seems very easy, but not so easy, because here the time measurements, for example, suppose the satellite sends the code at exact 5 o'clock and the receiver receives it at a time 5 o'clock and 2 milliseconds. So the difference is 2 milliseconds. But the time measurements are made at 2 different positions, right? The first 5 o'clock was measured in the satellite, and which depends on the satellite clock. Whereas the second time measurement, the receiver time measurement, that is 5 o'clock and 2 milliseconds, that is measured in the receiver clock. These 2 clocks are independent. They will not be synchronized at all. Means, when it is 5 o'clock in the satellite clock, it may not be 5 o'clock in the receiver clock. So this is called a synchronization error. 2 independent clocks cannot be synchronized. So to have perfect timing, perfect travel time measurement, 2 clocks has to be synchronized. The clock at the satellite and the clock at the receiver has to be synchronized. This synchronization is the biggest problem in GPS. So that has to be done. Even it is difficult, that has to be done. Otherwise, all your measurements will be wrong. 2 clocks must be synchronized. Since this is an introductory lecture, I am not going deep into the process of synchronization. For the time being, you understand that synchronization is a very serious process and it's a requirement in GPS. So once you have the synchronized time clocks, you can have the travel time, and from the travel time you can measure the distance of the satellite. So if you have three different satellites and three different distances, you can triangulate it. Triangulation is the process of intersection. You have three different spheres, and those three different spheres will be made to intersect, and you can know the position. But even with all these three steps, the fourth step is important, that is identifying and correcting errors. There are a lot of errors expected in these measurements. So let us see what are those errors also. So GPS or GPS signals will suffer from various errors. The signal which is sent from the satellite and it is detected in the receiver, in between the signal will have so many errors. So what are the causes of errors? As we have listed on the screen, you have the presence of atmosphere. You assume that your electromagnetic wave is traveling through vacuum, but it is not vacuum, it is actually atmosphere. So your velocity measurements may not be correct, velocity assumptions may not be correct. There is something called the multipath error. We will come to that. There are satellite errors expected, and there is the fourth error, which is selective availability. Let us see each of the errors in somewhat detail. So presence of atmosphere, I told you already, because signals travel through air, its velocity is not a constant, because air has got lots of variations, like the refractive index of air is not a constant. It depends on so many factors. You have a varying atmosphere at various times, so that error is there. When you calculate the velocity, when you calculate the time, the velocity may not be same always, because the medium is having a lot of changes. So if you have proper modeling to accommodate the daily variations of the atmosphere, morning air will be different from the evening air, or summer air will be different from the winter air. All these are some sort of a regularity can be obtained by modeling it. So if you are using proper models, you can just get rid of this error due to presence of the atmosphere. The second error is multipath error. Here, a receiver which is placed on the ground may receive different signals from the satellite. For example, it may receive a direct signal from the satellite. It is also possible that the receiver may receive reflected signals from other establishments on the ground. Some buildings, some antennas, some tall establishments, etc. will be reflecting the satellite signals. There will be different signals reaching on the receiver from the same satellite. So the timing will be different from different signals, and that will be a problem. So signal bounces often, and the same receiver may receive the direct signal and the bounced one. So this is sometimes it's very difficult to eliminate such errors, but there is one possibility that when there is multiple reflections, the signal intensity will be reduced. Okay, so you have one method to detect the intensity of the wave which is reaching on the receiver, and the one with better intensity will be the direct wave. So that is one method of just knowing the multipath error. And the third one is the satellite errors itself. This we have discussed to an extent, because the atomic clock which is used in the satellite is the most precise one, but it may not be perfect at all. So there will be some timing errors. And the orbits of the satellites may not be the same always. Of course, we are just updating it using the ephemeris data, but there will be slight errors, because every now and then it is not updated. Okay, so there will be an interval for the updation. So in between there will be slight errors for the satellite orbit. So when you are measuring the distance, actually you assume the satellite to be somewhere, it may not be at that particular place exactly. So there will be some errors in the distance measurement, and which will eventually make some errors in your calculation of or measurement of location. One another error is known as selective availability. This is not a natural error like the other errors which we have discussed. This is a purposefully introduced or imparted error in the system. And when US introduced this GPS concept for the first time, as we have discussed, that was for military applications or defense applications. So when it was given for civilian access, they purposefully introduced some errors into the system. The intention was that the civilian should not get the exact location. because that is because of the security concerns. Okay, military information should be different from the civilian information. So that is why they just purposefully did some error into the system. And it is said that after the year 2000, the US has officially removed this selective availability. And now civilians and the defense personnel both get the same signal. But how far it is correct, we don't know. Coming to the end of this session, let us discuss the GPS applications. The basic idea of GPS to know where I am and where you are, to locate something. So these are the scenarios in which you can use. It can be used in the expeditions, in the deserts, in the warfield, in surveying applications, to know your location, to know the location of others, etc., etc. And it can be used in tracking devices. Like your car can be equipped with a GPS device, so that if some theft has happened, somebody has stolen your car, the car will tell you where it is. And to know your own speed, you can use these GPS receivers. And to navigate, to know the distance to some place, or to know the speed at which you have to proceed, etc., etc. You can use this GPS. Another application of GPS is in the car navigation. Most of our cars have GPS equipments installed inside today. It's also used in ship navigation in ocean travels, also in aviation, air travel. In air travel, even zero visibility landing will be possible with the aid of GPS. The position of the runway is known and fixed, and the position of the aircraft, which is changing at a very instant, is also known with the help of GPS. So if these two parameters are known, aircraft can be landed in a very safe way. So GPS has got these tremendous applications, but we must be very careful on errors, because errors will produce a lot of mishaps. A lot of errors we have discussed which can creep into the system. So be careful on errors, as this very exaggerated cartoon shows. Say our GPS system is in kilometers and their system is in miles. So if that mismatch occurs, a lot of unwanted and unexpected things may happen. So as a concluding remark, GPS or the satellite navigation techniques have made the world very close, because the distances are not a problem today, the route is not a problem today, and the technology, the satellite navigation technology, has helped the world to unite. Thank you.